Welcome to the project demonstration of industrial SCADA implementation along with fencing alerts as well as three-phase fault detection. So here we are implementing SCADA system from these two boards. So one is voltage, current measuring potentiometers and a temperature and a optocoupler to check the frequency of this feeder. So here these four parameters will be continuously monitored with help of 16F8778 microcontroller along with fencing using this IR sensor and also three-phase fault switching with help of the switches. So whenever the fault is occurred is R, Y, B open circuit, then the fault will be identified by the same microcontroller. So coming to this interfacing connections of the input modules. So the SCADA board interface at A port is A0, A1, A2, A3 and IR sensor interface at E2 and the switches to represent the phase fault in the three phase. So that is going to be the C3, D0, D1 and output modules are relay D7. So it will connect it to the circuit breaker. When it is on, it's indicated as circuit breaker is on. When it is off, circuit breaker is off. And also buzzer indication whenever the abnormal is detected, and the so-called status will be displayed on the LCD screen along with voltage, current and temperature and frequency. And also if is any fault occurred of these three phases, that will be monitored continuously on this 16:2 LCD display. As well as also along with the buzzer, we are going to send the SMS alerts to this GSM modem. The whole system powered by this regulated power supply section. So here we are going to provide the 230 volts as input, and this transformer will step down the 230 volts AC to 12 volts of AC. So there will be 4 diodes on this board. So the diodes are connected in a manner of bridge rectifier. So this is a full wave bridge rectifier, and after that we will get the pure pulsating DC of 12 volts, and that particular pulsating DC will be converted into pure DC with the help of this 1000 microfarad capacitor. So it will remove the pulses after the rectification. So after this filtration we will get 12 volts pure DC, and that was given as supply to the our GSM modem. So the GSM modem has an inbuilt regulator, so which will provide the 5 volts constant regulated power supply that was given through these wires to our PIC microcontroller motherboard. So this is the 40 pin 16F8778 motherboard. Once it get the power supply, it start reading input from the input sensors, as well as it will control the output modules by using the interfacing these connections. So there will be one LED indication also is there. So this red light and this green light is a power indication. When we provide the power supply, so this light is indicated as power supply indication, and this one is a reset switch, and this one is a capacitor. After regulation there will be a chance of ripples. So in order to neutralize the ripples, we are making use of this capacitor, and this is going to be the 10 kilo ohm pull-up resistor for this reset switch. And this steel plated is a crystal oscillator which will provide the 20 megahertz of oscillating frequency. And these 5 pins are used to load the program into our PIC microcontroller. That's the Xcode loading into this system. So before switching on this kit, we need to insert a valid SIM card into this GSM modem. So that should be other than Geo, and it should have the SMS balance. I'm repeating, it should have the SMS or main balance, and better to use Airtel. Once insert the SIM card to this GSM modem, so just provide the power supply. And one more thing, after providing the power supply, hold this reset switch. Means we should hold the microcontroller till the GSM modem get the signal. So this green light is indicated very fast initially. Right, now it is slow down. Right, I'm repeating here. Just hold the reset switch till it slow down the blinking rate. Then only release the switch. Means the microcontroller will communicate to the GSM modem when we switch on the power supply. So we should hold the microcontroller till the GSM modem get the supply. Then only the commands which are going to enable the GSM modem to send or receive the messages, it will be executed properly after get the signal. So here we can see this, the voltage, current and the frequency is displaying on this LCD along with the temperature. Okay, so here the voltage and current, we are making use of potentiometers to change the input voltage and the current So frequency directly we are measuring from the main source, and the temperature we are making use of LM35. Okay, and IR sensor is to detect the obstacles. So once everything was settled down, we need to send a message to the system. So I'm sending the message of, so all should be small letters, that is help initially. So whoever send the message of help, so this particular number will be overwritten on this previous number. So from now onwards my mobile phone will get the message alerts. So the message will be received over here and will get the reply. So the reply message will consist of the data for how we to communicate with the kit. So now on or off to control this circuit breaker and get the total sensors parameters of the SCADA system, and IRY and IRN. So S now. So to enable and disable the IR sensor. So now it is disabled now. It's not working. Whenever you want to enable this security system, just we need to send the message of all are small letter again. I'm repeating, all are small letters. IR Y S. So just I'm sending the message. There we can see that the message will be received, and also will get the reply from the system. The IR system got enabled. So once it's enabled, from now onwards the system continuously monitoring fencing enabled, right? So whenever a person detected or an obstacle detected, so it will send a message alert to us. So that message consists of I have fencing alerts, right? I have fence alert, please check. So if I disable that, so again small letters IR N. Right. So again, so called message will be received here and it will be monitored. Once that message decoded, so we'll get the reply from the system. So IR fencing disabled. So now onwards the IR fencing will not work. So coming to this temperature increment. So once you increase the temperature, we can see the temperature increase, and when it crosses the 40 degrees centigrade, so the circuit breaker will get switched on. Okay, and also we'll get the message alerts. Right. So the 56 degrees. So the limit is 40 degrees. So coming to this voltage, just I'm increasing. When the voltage is above 240, so we'll get the high voltage and the message will be sent. Again current also 200 milliamps. The current limitation is going to be. Right. So we got the high voltage alert. So same low voltage is 180. Just I'm increasing the current now. So high current. So high current. Now coming to this phase fault. So when I isolate this, so the message will be sent to our phase fault to us. So till it's corrected, beeps will generated from the kit. So our phase fault, like that same thing, Y phase also, YB also. Just I'm replying to off the circuit breaker, because circuit breaker should be done manually. Sending off message. So the circuit breaker will be off by that by the message received. Right. So once the message received, it will be off condition. So you can send on to that also, and we get the reply. We'll get the reply. So I am replying to that to get the parameters. So we get the message of again. So when we send the get, so we'll get the live readings, voltage, current, temperature and frequency. Thank you.